Throughout my development journey, I've been building progressively more complex computer vision applications. My earlier work on opencv fundamentals gave me a strong foundation in working with images as datasets, which I then expanded on with facial recognition, using face encodings and real-time biometric processing. This hand-tracking Pong game represents the culmination of these computer vision skills, combining everything I learned into an interactive gaming application. This is a computer vision powered Pong game that supports both single player and two-player modes, where players control paddles using hand gestures detected through a webcam and MediaPipe. The game features real-time ball physics, collision detection, live tracking, and dynamic victory screens, all controlled entirely through hand movement. At startup, the system initializes MediaPipe's hand tracking module and opencv's video capture, then immediately prompts you to select between single player, pressing 1, or two player, pressing 2. This selection determines the entire game configuration, the paddle count, the paddle orientation, the collision detection logic, and victory conditions. Once a mode is selected, MediaPipe begins processing webcam frames in real time, detecting hand landmarks, and extracting 21 coordinate points per hand. These normalized coordinates are then used to control paddle movement. In single player, only the X coordinate of one hand is tracked to move the paddle at the top of the screen. In two-player mode, MediaPipe handness classification API identifies which hand is left and right, mapping the vertical Y coordinate of each hand to its respective paddle side. Left hand controls the blue paddle, while right hand controls the red paddle. The game engine runs a continuous loop that executes several operations each frame. It captures video input with opencv and processes the hand through MediaPipe, updates the ball position by adding velocity vectors to its current coordinates, checks for collisions with paddles using different hitbox calculations depending on the mode, and reverses velocity of the ball accordingly. It also manages game state by decrementing lives when the ball escapes out of its designated bound. It renders everything like the rectangles for paddle, circles for the ball, and text overlays for lives and game state using opencv and its drawing functions. So this is the actual application. I'll go over the code in a little, but to start the game, you just run the Python file, and then it will open up this window, which is the game. Now I'm going to start off with one player. So to play one player, it's pretty simple. You just type 1 on the keyboard. And after you type 1, it enters into one player mode. Now as you see, just pulls up a ball. And every time that I hit the ball gets faster. It's tracking my pointer finger. And I have 3 lives, which I think I wasted 2 of already. So after I die, I died. But I'm going to show you the ball getting faster. So I just died. Now I could click R to restart and play this game mode again. You see the ball is slower than how it was when it ended. So after dying, like I just showed you, you can either restart or you can click Q and it'll take you back to this screen. And then I'll click 2-player. Now you can play this actually game mode by yourself if you want to. This is my right hand controlling the red, and then this is my left hand controlling the blue. So as you can see with 2-player, it's a little different. It moves on the Y-axis instead of the X-axis. So up and down instead of side to side, basically. And I'm going to lock in with my left, just because I want left to win. Alright, and then it'll give you a blue screen if left won, and say I restart that, and then I let red win. Then it'll give a red display screen. Now if I click Q, it'll take me back to the intro screen, and if I click Q again, it shuts down the game completely.
The actual program for the Pong final. So it starts with 2 variables, which one being the start question, which is like enter key, and then a start key, which is a exclamation point. Now this is just acts at the start to start out the program. This is just the camera width and the height as it says. This is a paddle color. In BGR, this is just a green paddle, and this paddle would represent the single player paddle. The paddle X and then the paddle Y, the paddle is coordinates of where it is, and ball X and ball Y is the same as the coordinate of where it is on the image on the frame. And this is just where it starts, which is all for the frame, so it comes into the frame. And then ball coordinates is a tuple of the 2 coordinates, ball X and ball Y. And then create the ball, also circle on the frame, which would be pass in. It draws it at ball's coordinates, which gives you an X and a Y. This just draws draws a white ball at the thickness that you see on screen. MP hands is basically a class that imports MediaPipe as a self-definition. It defines itself, hands and B solutions, both hands, max hands, and then max hands is equal to 2, so it sets it for 2 hands for the max being 2 player. And then get hands, this basically just gets the hands from the frame. So it has an array, my hands, and then hands type. The frame, RGB, basically just converts the frame that you're passing in from BDR to RGB to run a process of getting the hands on that frame, because opencv works in BDR and MediaPipe works in RGB. This gives the results, and then we check the results multi-hand landmarks. And if that is not equal to none, then we have hands. Basically, for each hand in the multi-handedness, we give it handedness, which is basically if it's left or right, and then we give it the hands type. That's where we append the handedness. And then for each hand landmark and multi-hand landmarks, we create my hand array, not just the handedness array. So in the my hand, we have the hand data structure, which is comprised of a bunch of landmarks. So this represents one hand, and then this represents all the hands. And inside of this one hand array, we have the landmarks, and each landmark is basically a X and then a Y. And we have to multiply this by the camera width, the camera height, to get it to be scaled for the appropriate pixel position. And then we append that individual hand with each landmark, which there are 21 of 0 to 20 in the index. We append that to my hand, which contains all the hands, which each have the individual landmarks. We return my hands, the hands type, and these correlate, so we'll get the hand and if it's left or right all at once. This basically just sets the camera to the width and height that we defined earlier. And this sets the FPS. This returns a frame from the camera that we defined earlier. We get an ignore, which is a true or false flag that we got a frame, and then a frame, we flip that frame just because it's disoriented to play if the image isn't flipped. Like everything will seem like backwards or upside down. Start input is equal to input of start question, the first variable, start question, enter key, and if the input is equal to a exclamation point, then it'll run this, which basically just creates the camera, and then a game window sets the camera to a moving JPEG, and it sizes the camera, basically how big are the images that are coming in, makes a font, game selection screen, and this basically just reads the game mode from this. I have all the images, so it has game mode, a you died for single player, and then a 2-player you died, which has empty space to write who won, and it switches colors based off who won. So those are the images that's loading here. It just resizes one of them. Def screen, blue basically just converts the red one into a blue one. That's for left winning, and the base red one is for right hand winning. The hand AI variable is the MediaPipe hands class that we made earlier with the get hands function on it. After doing all that and initializing all that, it starts the main loop, which basically just shows a select screen until game 1 is pressed or game 2 is pressed. And based off that, it will print the 2 players and run each individual game, which I'll go over. 1 player first. Ball right is basically just if the ball is moving from left to right of the screen. Ball left is basically if the ball is moving from the bottom to the top of the screen. The lives is just how many lives you have. This is single player, and you click 1. But the ball speed is how fast the ball is moving. The paddle width is basically the X of the paddle, and the paddle height is basically the Y of the paddle. So it's 25 pixels tall and 125 pixels long. And then after that, that starts its own loop, which while true, will get a frame from the camera, pass that frame through MediaPipe to get handedness and the hands. For single player, we basically completely ignore handedness, and we only worry about the hands. There can only be one hand controlling the paddle at a time. All of these if statements are just for ball direction, switching the speed. If ball X right is true, then on the ball X coordinate, we're adding the ball speed, which is basically how many pixels it's moving per iteration of the loop. We update the ball coordinates with the updated ball X. And then if ball X right is equal to false, then we decrement the ball speed to move it on the left side of the frame, and then we update the coordinates. Then if ball X is less than or equal to the camera width minus 12, that's basically like the edge of the screen for the ball, and we set ball right to false, we start moving it to the left. If ball right is less than or equal to 12, that means it's all the way on the left. We set ball right to true. Now this is the same thing with the Y coordinate, it's just up and down. So instead of left and right, it goes up and down. If up is true, ball Y is plus equal to minus ball speed, so we're moving up on the frame. If ball Y up is false, then we add ball speed to move the ball down, and then we update coordinates in each of those conditions. This is basically checks. If it's at the bottom, then we set ball up equal to true because it can't go down any further. And then if it's at the top, remember we're in single player, so that's when we lose a life because that's where our paddle sits. Then we reset the coordinates to the bottom because you just died, so we're sending the coordinates back to the bottom. And if the ball hits the top 3 times, lives will be equal to 0. Then it will run this loop, which basically shows a def screen. It gives you a quit option or a restart option where it restarts all the necessary variables and breaks out of this loop. And then if continue solo is false, which happens when you click quit, it will be true if it's restart. Then it breaks out of this loop, and then it breaks out of the 1-player loop. This creates the ball. So this just draws the ball. Like I said, I went over that function earlier. It just draws the ball to the coordinates, and then it gives it the white color and size and everything. And it does that on each frame. It's just like constantly drawing the ball. And then after checking the collision detection, if you remember up here, we got the hands from the frame. So now we're actually handling with the hands that we got. So we basically loop through the hands in my hand. We draw a rectangle with the coordinates of the 8th landmark. We're getting its X coordinate, not its Y, because as we went over here, inside of that data structure, we have the landmark X and the landmark Y. So this is what we're appending. So in the 8th one is our pointer finger. So we get the X, which would be at index 0 of the 8th tuple that's inside of the hands. And that's how we get just our pointer finger in the X coordinate. And we get the Y later for 2-player. This draws a rectangle how we want it with the color that we set. This just makes boundings for the rectangle to detect if the ball is anywhere inside of it. And this is how it actually checks for collision against the rectangle that we made, not just the sides. If it hit collision, that means the ball should no longer be going up because it hit the paddle. It's going to turn around and go back. And then it sets ball speed to +1. So basically it gets faster each time that you hit it. And then CV2 I'm show game window.frame just shows the frame that we've been drawing every single thing on. Got the hands from it, the circle on it, do the rectangle on it, show it in the game window after we collect, detect for every collision. And then if you want to quit while you're outside of this loop, you can just click Q, and then it breaks out of the 1-player loop as well. Now 2-player is basically the same, just with it being on the Y-axis and then having some slight differences. Ball X right, ball Y up, we're still using those coordinates to detect how the ball is moving. You got 5 lives. for right and left. The ball speed starts off the same. Makes the ball coordinates at the bottom of the screen, and then the paddle width is different, and the paddle height is different inside the 2-player. So wild truth is basically runs a 2-player game loop, takes a frame, does collision detection, but the difference is instead of going up and down, we're checking left to right, and it takes down a life from left, because that means the red side got it all the way over there, and then it prints out the life, and then it makes it fall, so it starts moving to the left towards the red paddle. Here, ball X is less than or equal to 12. That means it's all the way to the left of the screen where the right hand is controlling it. Then it takes away a life from the right side, and then it takes ball X right to true to move it towards the right side. And then the Y is basically the same as the X from last time. Logic is right here, but I'm gonna move it because I just noticed that. We removed the code, but this basically is like whoever won, it draws who won. Now this actually gets the hands, and this draws the hand. So hand type is equal to 0, it draws a blue hand. And then hand type is equal to anything else, it draws a red hand. So this would be left right here. Just draws the left, everything. And then just checks collision on the paddle. It puts up the ball speed by 2. This basically draws the right. This checks for collision on the right, up by 2 each time you hit it. And then this draws the circle basically on the hands that you see in the color. And then this puts the text of the lives. This draws the ball. And then this finally shows the frame that you've been drawing everything on. And then if you click Q, it quits. Then you go back to this main screen where it actually 1 or 2. Then if you click Q again, it breaks out of the loop and the program stops running.